Hello and welcome to LSAT Logic Applied. I'm your host, Andrew Leahy, an assistant teaching professor of law at Drexel Klein School of Law. This is a short format podcast where I take the tools from LSAT logical reasoning, assumptions, flaws, causation, strength, and weaken, and apply them to real world claims in the news, science, and public discourse. For those that don't know, the LSAT is the law school admission test, a standardized exam designed to assess logical reasoning, analytical thinking, and reading comprehension for law school applicants. It's a high stakes test with a unique focus on how arguments work and how they fall apart. The LSAT is owned and administered by the Law School Admission Council, or LSAC. I don't claim any affiliation or ownership, I'm just here to teach the logic. And you don't need to be studying for the LSAT to follow along. The point is to learn how to spot weak or incomplete reasoning in everyday life, the same kind of reasoning the LSAT trains you to attack under time pressure. Today's episode looks at a striking medical headline about irritable bowel syndrome medications and mortality, and it asks a very LSAT-style question. What exactly follows from an association? Here's the background. A new study in communications medicine examined more than 669,000 adults with irritable bowel syndrome, or IBS, using a large nationwide electronic health record database. The researchers found that some medications used in IBS patients, most notably antidepressants, and in IBS-D patients, loperamide and diphenoxylate, were associated with higher all-cause mortality over long-term follow-up. Other medications, including antispasmodics and several FDA-approved IBS therapies, were not associated with the same increase. The paper is fairly careful in its wording. It repeatedly speaks in terms of association, not proof of causation. It describes a retrospective cohort study, uses propensity score matching across 56 covariates, and even tries active comparator and target trial emulation methods to reduce their own bias. But once the study gets translated into headline form in the news, the implicit public-facing argument starts to look something like this. Some IBS medications are linked with higher death rates. Therefore, those medications may be dangerous, or more strongly, those medications increase the risk of death. That is exactly the kind of move the LSAT wants you to slow down and inspect. The structure of the argument looks roughly like this. Patients with IBS who took certain drugs had higher rates of all-cause mortality than matched patients who did not take those drugs. The association persisted across several subgroups and analytic approaches. Therefore, the drugs themselves are likely contributing to the increased mortality. Now, to be fair, the study itself is not junk. The data set is huge. The matching is extensive. The authors also note that antidepressant users had higher mortality than non-users with a hazard ratio of 1.35 overall, and that the association persisted across subclasses like SSRIs, TCAs, SNRIs, and mirtazapine. In IBS-D, loperamide and diphenoxylate also showed elevated hazard ratios, and the figures reinforce that pattern. The chart on page 5 of the actual study, if you're interested, it's linked in the show notes, shows elevated hazard ratios across the antidepressant subclasses, while the chart on page 7 shows higher hazard ratios for loperamide and diphenoxylate in IBS-D patients. So all that study jargon aside, the conclusion does not come out of nowhere, but it is still an inference, and that inference has vulnerabilities. First, we have the big one, causation versus correlation, our old friend. The study found an association. That means two things move together, use of certain medications and higher mortality. But on the LSAT, correlation alone does not get you to causation. Something else may explain the relationship. For example, maybe the patients prescribed antidepressants were sicker in ways the dataset could not fully capture. Maybe they had more severe IBS, more psychiatric comorbidity, more chronic pain, or more complicated health profiles overall. The authors tried to control for confounding with propensity score matching and active comparators, but they also explicitly acknowledge the possibility of residual confounding and unmeasured variables. That matters a lot. On the LSAT, this is the classic alternative explanation problem. Then we have confounding by indication. This is the more technical version of the same flaw. Why do people get prescribed these drugs in the first place? Usually because something about their condition, symptoms, or history makes a clinician think the medication is warranted. That creates a risk that the medication is acting as a marker for a higher risk patient population rather than as the cause of the later outcome. The paper tries to deal with this by using antispasmodics as an active comparator and by excluding prior antidepressant users from some subgroup analyses. And that helps, but it does not eliminate the possibility that the treated and untreated groups differ in important ways that are hard to measure in claims-style data. So an LSAT question would be, did the study isolate the effect of the drug or only identify the profile of people likely to receive the drug? There's another important reasoning point here. The study's primary endpoint is all-cause mortality. That is broad. That is very broad. The benefit of using all-cause mortality is that it avoids some gamesmanship about cause-of-death coding. But the downside is that it does not tell us what mechanism is doing the work. If a drug is associated with higher mortality, is that because of cardiac risks, falls, suicidality, polypharmacy, underlying depression, or something else entirely? The authors discuss several possible mechanisms and note increased associations with things like arrhythmia, hypertension, falls, GI bleeding, and suicidal ideation. But they also admit that their platform prevented cause specific mortality analysis. On the LSAT, that is a gap between the outcome measured and the explanation offered for it. There is also a subtle issue of overreading. A headline may say something like common IBS medications linked to higher risk of death. That is technically closer to the paper than these drugs are deadly, but audiences often hear the latter anyway. And that's a familiar LSAT problem. An argument presents evidence that supports a very cautious conclusion, then the rhetoric slides toward a stronger one. The paper's conclusions is that the findings just raise concerns and underscore the need for cautious prescribing and further research. That is very restrained. It is not the same as saying the drugs have been proven unsafe in a causal sense. So the question becomes, are we drawing the conclusion the evidence supports or a stronger conclusion that sounds more dramatic? And another good LSAT style move is to distinguish relative effect from absolute magnitude. A hazard ratio of 1.35 sounds dramatic, but the underlying mortality figures reported for antidepressant users versus non users were about 1.6% versus 1.0% in the matched cohort. That is obviously still important, but it is different from hearing 35% higher risk in the abstract and imagining an enormous absolute jump. The same issue shows up in the IBS-D findings for loperamide and diphenoxylate, where hazard ratios are large, but the event counts are comparatively small. The figure on page 7 of the study notes that small cohort sizes and rounded counts may affect results for infrequent outcomes. On the LSAT, numerical framing matters. A statistic can be technically true and still rhetorically misleading if you do not ask what it means in practical terms. So what's missing? How can we boost or bust the argument? To strengthen the argument, we would want to know whether similar results appear in larger data sets, not just TriNet X, which was the data set here. The authors themselves say outside validation is necessary. Whether more granular data can isolate the role of underlying psychiatric illness or pain conditions, medication dose, misuse, or polypharmacy, and whether cause-specific mortality data points toward a plausible and consistent biological mechanism. The argument would also be strengthened by randomized evidence, though for obvious reasons, long-term mortality trials here may be impractical. On the other hand, the argument is going to be weakened if the apparent effect shrinks materially once more detailed clinical variables are measured. The elevated mortality is mostly explained by the kinds of patients who receive the medications rather than the medications themselves, or the signal turns out to be concentrated in subpopulations with very special risks, like misuse, overdose, severe comorbidity, or concurrent medications, rather than routine prescribing as such. In other words, the key missing piece is not just whether there is an association. There clearly is. It is whether the association is best explained by the drug itself or the patient population that we're looking at. This episode is really about one of the oldest LSAT lessons there is. An association is not the end of the analysis, it is in fact the beginning. The study here is serious and worth attention. It used a very large cohort, found consistent signals for some medication classes, and raised legitimate reasons for caution. But the logic still matters. A careful observational study can justify concern without conclusively proving causation. So the right LSAT questions are we confusing association with causation? Have we ruled out plausible alternative explanations? Does the mechanism actually match the outcome being measured? And are we drawing a conclusion that fits the scope of the evidence? Because in medicine, as on the LSAT, the hardest reasoning errors often happen when a real pattern gets translated into a stronger claim than the evidence can fully carry. With that, I thank you for listening to LSAT Logic Applied. If you enjoyed this breakdown, subscribe for more short episodes where we apply clean logic to messy, real-world claims. See you next time.